Hello everybody. Lesson 7 part 1. Let's continue topic concrete. Continuation. Water for concrete. Water in concrete has two important functions. First, it mixes with cement powder and results in the hydration reaction commencing, which ultimately results in the concrete hardening. But the concrete also needs to be placed, and the term used to describe this is concrete workability. To be workable, concrete needs more water in the mix than just for hydration. This water either remains trapped in the concrete matrix after the concrete has hardened or evaporates, resulting in a degree of permeability being imparted to the mix. Adding too much water increases the permeability, which reduces both concrete strength and durability. The water used in making of concrete must be clean and free from contamination that could affect the concrete. A proportion of water will set up a chemical reaction which will harden the cement. The quantity of water to be used in the mix is usually expressed in terms of the water-cement ratio, which is total weight of water in the concrete divided by weight of cement. For most mixes, the ratio is between 0.4 and 0.7. Usually, if water is drinkable, it will suffice to concrete, unless sweetened by sugar. But it's important to note that organic impurities in the water can cause retardation of the mix, and water must be free from chlorides, as this can cause steel in the mix to corrode. Acids and sulfates in the mix water can have detrimental influences, but this only occur in the long term. Eurocodes 1008 specifies the quality of water required by a practical means of checking that water is acceptable is to make trial mixes using the available water. Long-term effects cannot be highlighted but most other problems will be evident. Recycled water is now being used routinely in many ready-mix factories, where a series of large linked settling ponds enables the water to be purified and reused. Traditionally, concrete mixes expressed as prescribed ratios of the constituent parts. For example, 1 part cement by 2 parts fine aggregate and 4 parts coarse aggregate. Typical mixes are follows. 1 by 10, not a strong mix, but suitable for filling weak pockets in excavation. 1 divided by 8, little better than the last, suitable for paths and pavings. 1 part cement, 2 parts fine aggregates, and 6 parts coarse aggregates. A basic mix for general purpose mass concrete works. And the last, 1 part cement, 2 parts fine aggregates, and 4 part coarse aggregates. This is a strong mix that is practically resistant to water, used especially for reinforced concrete. Admixtures. Admixtures are materials that are added to plastic, concrete to change one or more properties of fresh or hardened concrete. These admixtures speed up the chemical reaction in concrete both while the mix is weighed and subsequently. Hence, concrete with this admixture both hardens and gains strength quicker than untreated mixes. The concrete remains workable when first mixed and achieves similar 28-day strength to untreated concrete. Admixture is a material, usually a liquid, which is added to a bath of concrete during mixing in order to modify the properties of the fresh or hardened concrete. Nowadays, admixtures are added to most mixes, and in some cases they are essential. Because admixtures are added to concrete mixes in small quantities, their inclusion should be carefully managed. Incorrect dosage of an admixture, either too much or too little, may adversely affect the strength and other properties of the concrete. Your code specifies the requirements for the common admixtures: accelerating water reducing, retarding water reducing, normal water reducing. This is a plasticine. High trench water reducing, super plasticine. Water resistant, this is a waterproofing, and air entering admixture. Until 1977, the most widely used accelerator was calcium chloride, either as a proprietary solution or in flake form, because the presence of chloride, even in small amounts, increases the risk of corrosion of embedded reinforcement. The use of admixture based on calcium chloride is now prohibited in all reinforced and prestressed concrete. But In plain concrete not containing any embedded metal, chloride-based admixture may be used when early rapid hardening is required, in which case a dosage rate of 1.5% anhydrous calcium chloride by weight of the cement will usually be sufficient. To fresh concrete, added to influence its workability, setting times and heat of hydration, and to hardened concrete, added to influence the concrete's durability and strength. Types of admixtures: chemical admixtures and mineral admixtures. Chemical include accelerators, retarders, water reducing and air entering, and mineral strength and durability. Chemical admixtures. Accelerating admixtures, compounds added to cement to increase its setting time and to improve the early strength development, used in cold weather, concreting 25% of strength gain observed at the end of 3 days. Calcium chloride less than 2% by weight of cement. Retarding admixture, added to concrete to decrease its setting times. Used in hot weather applications. Sodium or calcium tritanolamine salts of hydrogenated adipic or gluconic acid. Water reducing admixtures and superplasticiter used to reduce the amount of water. Used in concrete mixtures. High-trench water reducers reduce the water required for mixing by 12% or greater. Added to improve the consistency, workability of concrete and increase the strength. Water reducers. And this is lignosulfates, hydroxylated carboxylic acids, carbohydrates, superplasticizers, sulfonated melamines, naphthalene formaldehyde condensates. Formaldehyde condensates. The next admixtures, air entering admixtures, as it allows spreading of microscopic air bubbles. Allows spreading of microscopic air bubbles, diameters ranging from 20 to 2000 meters throughout the concrete, decreases the freeze, defrost degradation. The next, mineral admixtures. Used in concrete to replace part of cement or sand. Added in large quantities compared to chemical admixtures. Example, fly ash. Byproduct of coal from electrical power plants, finer than cement, consists of complex compounds of silica, ferric oxide, and alumina, and increases the strength of concrete and decreases the heat of hydration. Silica foam. Byproduct of electric arc furnaces, size less than 0.1 mm, consists of non-crystalline silica. Increases the compressive strength by 40–60%. Mixing involves weighing out all the ingredients for a bath of concrete and mixing them together. Mixing can be hand mixing, machine mixing, and ready mixed. Hand mixing. This should be carried out on a clean, hard surface. The materials should be thoroughly mixed in the dry state before the water is added. Machine mix. This mix should be turned over in the mixer for at least 2 minutes after adding the water. Should be turned over in the mixer for at least 2 minutes after adding the water. And ready mixed. This is used for large batches with lorry transporters of up to 6 cubic meters capacity. It has the advantage of eliminating site storage of materials and mixing plant, with the guarantee of concrete manufactured to quality control standards. So this is ingredients, a component to use to prepare a concrete. This is a hand mixing. This is a machine mixing, and this is a ready mixed with lorry transporters. Handling and placing. Concrete should be placed as soon as possible after mixing to ensure that the hardening action has not commenced. Concrete that dries out too fast will not develop its full strength. Therefore, new concrete should be protected from the drying winds and sun by polyethylene sheeting. or being regularly sprayed with water. Protection should be continued for at least 3 days because concrete takes about 28 days to get its working strength. Pumping. Concrete is conveyed to the construction site in wheelbarrows, carts, bell conveyors, crans or chutes or pumped high-rise building. Pumps have capacities to pump concrete up to 300 meter and at 150 cubic meter per hour. Concrete should be placed as near as possible to its final position, placed in horizontal layers of uniform thickness and consolidated before placing the next layer. Finishing. The concrete must be leveled and surface made smooth flat. A smooth or flat. Smooth finish. Float or trowel finish. Broom finish. And exposed aggregate finish. This is a transit mixed truck, or you can say a ready mixed truck. In transit mixed concrete, all the raw ingredients are loaded directly into the truck mixer. No plant mixer is involved. Some or all of the mixing water is usually introduced at the plant. The mixer drum is rotated and charging speed during loading. And how does cement come out of the truck? The concrete mixing transport truck maintains the material's liquid state through agitation or turning of the drum until delivery. The interior of the drum on a concrete mixing truck is fitted with a spiral blade. In one rotational direction, the concrete is pushed deeper into the drum. Transit mixed concrete, also known as truck mixed. Materials are batched at a central plant and are completely mixed in the truck in transit. Transit mixing keeps the water separate from the cement and aggregates and allows the concrete to be mixed immediately before placement at the construction site. That's very convenient.